Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC B1011, MICU loss communication with the gauge control module in a 2006 to 2011 Honda Civic. This diagnostic trouble code indicates that there is an issue with communication between the microprocessor interfacing control unit, MICU, and the gauge control module responsible for monitoring various vehicle metrics. The gauge control module enables functions like monitoring speed, fuel level, and engine temperature. If this communication fails, it can lead to inaccurate readings on the dashboard and possible malfunctions in vehicle operations. It's crucial to address this issue to ensure that all vehicle readings are reliable. In this presentation, we will provide detailed descriptions, possible causes, symptoms, troubleshooting steps, and preventive maintenance advice related to DTC B1011. The error description for DTC B1011 indicates that the microprocessor interfacing control unit, or MICU, is unable to communicate with the gauge control module. The MICU acts as a central control unit that interacts with various electrical components within the vehicle, particularly related to gauge functionality. The gauge control module, located behind the dashboard, is responsible for providing drivers with important information such as fuel levels and engine temperature. When the communication line between these two components is compromised, it leads to a breakdown in reporting important vehicle status metrics. Understanding this relationship and their respective locations is critical in the process of troubleshooting this DTC effectively. The failure to communicate not only affects driver awareness, but can also lead to potential issues in vehicle operation. When diagnosing DTC B1011, it is essential to consider several possible causes. First, loose or poor connections at the gauge control module, TAC, 36P connector could hinder proper communication. This connector serves as the communication line between the MICU and the gauge control module, and any disconnection might lead to a lost signal. Secondly, the gauge control module itself could be faulty, leading to a breakdown in its ability to send or receive messages. Lastly, an open circuit in the communication line between the MICU and the gauge control module is another potential cause for this error. Identifying these issues is the first step to resolving DTC B1011 and restoring normal vehicle operation. The symptoms associated with DTC B1011 primarily revolve around inaccurate readings from various gauges on the dashboard. Drivers might notice that the fuel gauge does not accurately reflect the fuel level, or the engine temperature gauge could show incorrect values. Additionally, warning lights may illuminate on the dashboard, indicating further issues within the vehicle's systems. This can lead to driver confusion or misinterpretation of the vehicle's status, which could result in neglecting necessary maintenance or repairs. If the problem persists, there could also be noticeable performance issues with the vehicle itself. So it is crucial to address this DTC promptly to avoid further complications. The first step in troubleshooting DTC B1011 is to clear the diagnostic trouble codes using the Honda Diagnostic System, or HDS. This system is a specialized tool designed to access various vehicle systems and retrieve codes that indicate malfunctions. Once the DTCs are cleared, it is essential to turn the ignition switch to the lock position and then back to the on position, which is typically the second position of the ignition switch. By waiting for at least 6 seconds, the vehicle's onboard systems can reset and prepare for a new diagnostic cycle. This step is crucial because it ensures that any temporary faults are eliminated before proceeding with further diagnostics. It sets a proper foundation for accurate testing in the subsequent steps. After clearing the codes, The next step is to check for DTCs once again using the HDS. It is particularly important to see if DTC B1011 is retrieved during this check. If B1011 is indicated, it confirms that the communication problem persists and requires further investigation. Conversely, if B1011 does not appear, it suggests that the issue may be intermittent or resolved, indicating that the gauge control module is functioning correctly at that moment. It's crucial in this process to always use the HDS as it provides real-time data about the vehicle's performance and any existing issues. This step is integral to isolating and confirming the issue specific to the gauge control module. In this step, the technician checks for additional diagnostic trouble codes using the HDS to see if DTCs B1008 or B1032 are present alongside DTC B1011. These specific fault codes indicate other issues within the vehicle's electrical systems that might be contributing to the communication loss between the MICU and the gauge control module. If either of these codes appears, it suggests a more complex communication error involving additional components. Conversely, if these codes are absent, the focus shifts to the input test of the gauge control module, TACH, suggesting that the further investigation should proceed in that direction. This thorough checking helps to ensure that all potential contributing factors are considered in the troubleshooting process. If DTC B1008 or B1032 are found alongside B1011, the next step is to check for any open circuits in the communication line between the MICU and the gauge control module. This communication circuit is critical for relaying information between these components. Thus, any break or fault can lead to the codes being triggered. This diagnosis requires a thorough inspection of wiring and connectors for any signs of damage or disconnection. If an open circuit is detected, repairs must be made to restore proper communication. If no faults are found in the circuit, then the problem may be within the MICU itself, necessitating its replacement or further troubleshooting in that area. This thorough check is vital for rectifying issues and ensuring the vehicle operates correctly. After completing the necessary repairs, it's essential to perform a final verification to confirm that the issue has been resolved. This involves using the HDS to recheck for any existing DTCs. If no codes are present, it indicates that the prior communication issues between the MICU and the gauge control module have been effectively corrected. It's important to ensure that data is accurately transmitted and received to confirm full functionality of the vehicle's gauge systems. This final check not only provides peace of mind, but also validates the efficiency of the troubleshooting and repair processes undertaken. Depending on the vehicle's stability post-repair, further road tests could be advised to ensure operational reliability. To help prevent future occurrences of DTC B1011, regular preventive maintenance is highly advisable. Periodic inspections of wiring and connectors, particularly at vulnerable points such as the gauge control module and the MICU connections, are essential in maintaining the integrity of the vehicle's electrical systems. Ensuring that all connectors are secure and free from corrosion or wear can significantly reduce the risk of communication failures. Additionally, keeping the battery condition in check, along with the charging system, can prevent power-related issues affecting these components. Developing a robust maintenance schedule that includes these checks can greatly benefit the long-term health of the vehicle. Prevention is always more efficient and cost-effective compared to troubleshooting later on. In conclusion, DTC B1011 signifies that there's a communication issue between the MICU and the gauge control module in the Honda Civic models from 2006 to 2011. It's critical to thoroughly examine the wiring and connectors for defects or disconnections. Utilizing the HDS efficiently allows for precise diagnostic checks and ensures that all potential fault codes are identified and addressed. Following the outlined troubleshooting steps methodically helps in restoring vehicle functionality to normal levels. Lastly, prioritizing preventive maintenance can significantly alleviate the likelihood of similar issues arising in the future. Understanding these aspects can empower technicians and vehicle owners alike in maintaining the vehicle's operational reliability effectively. Please like and subscribe to the channel. See you next time.